Hello everyone, welcome to my channel. If you're watching this video is meant to be a quick fix for those who are not quite getting the different scientific variables. So first of all, a scientific variable is a condition, factor, or trait that can be found in various amounts within an experiment. So there are three different types of variables. There is the independent variable, the dependent variable, and the control variable, also known as the fixed variable. The independent variable is the variable of an experiment that is purposefully changed by the person conducting the experiment. Another way to think about it, it is the part of the experiment that you are directly controlling. If you look at an example of that, well, first off, an easy way to tell an independent variable from a graph is that the independent variable will always be along the x-axis of a graph. So it'll always be found on the x-axis. In this case, it is the intensity of light. So this graph shows the how light intensity influences rate of photosynthesis, and light intensity being the independent variable is what is being controlled by the person conducting the experiment. So he can either increase the amount of light that the plant receives or decrease the amount of light that the plant receives. Then next up is the dependent variable, and this variable is the variable of an experiment that is influenced or dependent on the changes of the independent variable. So it depends on how the independent variable changes, and that will change or influence the dependent variable. Another way of thinking about the dependent variable is to think about it along the lines of the change you are observing. So what you are observing in the experiment, like what's changing as you look at the experiment because of the independent variable changing, what is that affecting? Again, if we look at the same experiment with the intensity of light and photosynthesis, we can see that as the light intensity, as the independent variable, where the light intensity, as it increases, so does the rate of photosynthesis. So in this case, the dependent variable is the rate of photosynthesis, so how fast photosynthesis is happening. And as we increase our light intensity, we can see that the rate of the photosynthesis is also increasing right up to this point over here. And then after that, it just sort of flatlines where there's no more increasing. And what that tells us, what the graph is telling us here is that there's a certain point at which plants don't take in any more light. So once they receive a certain amount of light, they just stop absorbing light, and then it no longer will influence how fast they photosynthesize because they're not taking in any more light. They just stop taking in light at that point. But yes, so in this case, our dependent variable is the rate of photosynthesis, which is influenced by how much light a plant receives. Next up is our fixed or our controlled variable, and this one is very simple. It's the variable of an experiment that does not change. So it does not change throughout the whole experiment and is kept the same for the sake of fairness and accuracy of results. It's another way of thinking about it is it's the thing you keep the same. So again, if we look at the same experiment with the rate of photosynthesis and light intensity, our fixed variable would be the fact that we only use sunflowers as a plant. So all our plants that we use in this experiment are all sunflowers, so that the results can be fair. Right, we're looking at the same species of plant, sunflower. Or it can be the fact that we only use sunlight as a source of light and not different types of lights, or like, for example, electrical lights or lamps. Just all sources of light come from the sun. And another fixed variable could be that this experiment always happens within an hour. So this result that you see here is always within an hour of time. We do not give it more time. And that's, for example, what does not change no matter how much times we do the experiment. Those are always the same variables. Right. So if you look at another example, completely different one, we can see that this graph shows solubility of salt and sugar. So here we can see our line showing salt solubility and this line showing sugar's solubility as the temperature increases. So straight up from, I mean, you already know, and maybe I should give you a chance here. So see if you can identify first the independent variable, then the dependent variable, and then try to see if you can spot any fixed or control variables. You're welcome to pause the video to do this. If you're happy with it, I will continue. So if you have done it right, then you would have said that the temperature is the independent variable. Another way that it was easy, it was that it's on the x-axis. So the temperature is the variable that is purposely being changed by the person doing the experiment. So he or she is increasing the temperature, and that is affecting how soluble, or rather how much sugar or salt can be dissolved within the 100 milliliters of water. So we can see here from the results that when it comes to salt, as you increase the temperature, there's not that much change in how much salt can be dissolved in 100 milliliters of water, which tells you that the solubility of salt is not affected that much by temperature. But if we look at sugar, we'll see that there is a big increase in solubility of sugar as the temperature increases. So as we increase the heat of the mixture, so does the amount of sugar, or the amount of sugar that can be dissolved in the mixture also increases. Which brings me to the last point I just want to mention, is that we get different types of lines in a graph, or different types of graphs we can observe. The first one, the sugar, shows a non-linear graph, and that's because the line that it is produced by the results is not straight. We can see that it curves up. So that means that the change between the x values, or the x values, so the independent variable and the dependent variable, are not a constant change. It's basically what happens here is that the y values are increasing much faster than what the x value is increasing, creating this sort of upturn of the line. And then here for the salt line, we can see that it's linear because the line is straight, what that means is that the change between the x and the y is a constant change, and in this case it's a very small change, which is why the line looks almost horizontal, but it does sort of go a little bit up. All right, I hope that you found that helpful, and never stop learning. Stay awesome. Till next time.